flattening it up, they're going to then install the outer face, right? And then they will pour the concrete and vibrate. Put on, right? Everything here is well calculated and measured as it has to be.
Welcome back everyone to another video. So today I was invited by Factories Corporation Jamaica to come on a tour with the St. Elizabeth Technical High School students, some of them who are interested in the engineering field. So big shout out to Factories Corporation Jamaica for inviting me, and stay tuned and watch as I take you on the tour along with the students of the St. Elizabeth Technical High School.
You won't be in the sun for long. We're just going to greet you this morning. Take you on a tour of the site. And then we have some discussions. And you are free to ask any question you so wish as we speak about your own development and your own future in the area of engineering. Right? So I want to thank the teachers
led by Mr. Baker.
Falling and going straight, people together as a group because it's an active construction site and things can happen. We don't want anything to happen to you all. We want your safety and our responsibility. So you will follow us where we're going. We will stop at each location. We will describe the location for you. And then when you get back in a safe environment, which is the NCD building, you can ask those questions. So take a mental note of what you want to ask, if you wish, and we will be prepared to answer them. So there's no test. You have enough tests from school. This is just break from the mental strain.
So if you can just see them to the...
So I'm going to take you to the NCD.
Oh, they're bad?
Okay.
All right. Shirley, as well as the Morant Urban Center, Managing Director of NCD, that's the Donald Carter. Now you're talking about two St. Elizabeth man right here.
Right. And so I'm engineer.
And of course, Kurt Kennedy, and he's the head of Head Carter Construction and Project Management Company. So these are your touring parties for the day. Can you just introduce yourself?
Alright, so first of all, I am Roman Diego, teacher of technical drawing and building construction at STEM. This is Mr. Barrett, Camilo Barrett, also teacher of technical drawing and building construction. Mr. Kelly, also a teacher of technical drawing. Mr. Darrell Kelly, teacher of technical drawing and building construction.
And I just want to reinforce, I went to St. Andrew Technical High School. So when you talk about drawing and all these things, you bring back some good memories, right? So it's good to have you, good to know that you're leading a team of young engineers, and we are proud of your work, and we hope this visit with your students will inspire you and inspire them also to be focused on the area of engineering and to understand that it is a very important field that we look towards to make a development for the future. You'll hear people talk about Singapore and all the advanced countries, and you look at the design and the building and the sophistication of what they do. This is going to be the remit of these young students. They are going to be the future of Jamaica, designing, building out to make Jamaica a better place that we can all be proud of. So I want you to thank you again, and we will try to make the tour as educational and interesting as we can. So God bless you. And I see you have my friend here, right? I like the idea of your wit, of your challenge, and being in a wheelchair doesn't make you any less important or capable. Some of the most brilliant minds are challenged one way or the other. So I'm happy to have you, and you are an example of all the other young men who are challenged and succeed. So you are very special welcome this morning. Let's introduce the rest of but she's a well-qualified engineer, and she's on this side as one of the oversight engineer and the project management.
And she's from just up the road from them actually. She's
Right.
from Westmoreland.
Yes. So hopefully, as I will elaborate later on, the whole idea of the government mandate to build our communities is that in the future, all these young engineers don't have to migrate anymore. They can stay within their zone, their communities, and build out and invite us to do projects of this nature. But we'll save that for when we finish the tour. Right.
College, welcome to
I don't know about
What color?
Thank you again, Carol. Welcome. This is going to be just a short introductory talk, and then we'll go on the side, and then when we come back with your talk session, I just want to emphasize that this is not only a core of your field of discipline in the engineering and construction, it's also a core to allow you to understand leadership, team spirit. So this morning I'm going to ask two persons volunteer to be responsible for the team. Alright? Who else volunteer? Beautiful. I know, so we have a male and a female. You know your team. Ensure that they are accountable for, they're following where we go, no strain. And the emphasis will not only be on the teachers, but on you two as the leader of the team this morning. Fair enough? So, welcome again. We will now hand over to Mr. Kirk Kennedy, President again of Cape Castle, who is responsible for the oversight, all the engineering oversight and development of this massive 436,000 square feet of development.
All right. Good morning, ladies and gentlemen. No, I don't travel from far. Let me say it again. Good morning, ladies and gentlemen. Good morning, sir. Sounds much better. Sounds like a real sense of respect. Good morning. All right. So this is an active construction site, right? What that means is that construction is going on as we speak, which means that construction will be going on while we are touring. So we have to be very vigilant. Is there anybody here who has either a sight deficiency or a hearing deficiency? Okay, great. We know we have. What's your name again? Sorry? What's your name? Yes. Khaled? I know we have Khaled who want to play some football, but you're going to do it tomorrow, not today. Right, Khaled? But you're welcome here as well. We cater to everybody here. Just to say that as we go through, there's some things that I want you to know. When you're looking up, if you hear any noise, don't make the first thing you do is look. Allow the noise to go over while you stand still. The reason for that is sometimes you have items coming down from up, coming down, and somebody says, and you look, it comes right in your face, and you, so all you have on hard hats, if something's coming down, that's where you want it to hit, right? And that's what's protected here in the head, right? Now, we also want to ensure that the persons, you follow the commands that you're given, right? So if we say we're going to the left, now we don't want everybody to be following us, right? We're going to the right, everybody's following us, right? And let us keep ourselves in tightly group bunches so that they're easy to, one, be accounted for, and two, the way in which the tour is going to take place, the activities, though present, we are a little bit curtailed to allow the tour to happen. So we don't want to be over here and curtail the activities somewhat and you're somewhere else where the activities are in full force and something happens, right? We're not going to go into the safety shoes because some may have on safety shoes and some doesn't, or some don't. For those, we're going to also ask you when you step in, the steps must be measured and you know as to where you're putting your feet, right? Because we don't want anybody stepping on steel, stepping on nails, anything such as that, right? Safety is your responsibility, right? So we just want to ensure that persons understand that. And safety starts and ends with you, and it starts now.
As was said earlier, I think of myself as a sentence boy. I'm actually from the hills, Spring, Monino, Bumpo, Newmarket, YS, Spring. Unfortunately, I think that but as a cricketer, I competed strongly with you guys that you all produce some amazing cricket in my time.
That's just one of them.
Yeah.
T20, I think. Yeah, they just want to T20. They probably don't know. They just want to.
So one of my experiences bowled for naught while playing against you guys in a friend. You don't have that up against you guys. But I mean, I'm just happy to see you guys. When I went to high school, I did science and arts,
So you did a couple science courses, accounting and geography and other type of courses. I'm told that you guys are studying building technology. So your preparation to become an engineer is right ahead. And a matter of fact, to get the opportunity to be in a place like this, to see a massive construction like this happening, to me that is significant motivation. So I look forward, Chairman, after we move that walk, to interact a little bit. So guys, let's walk, let's learn, and please be safe.
Hold on, let me just make one point about this construction site. It speaks about fortunate you are. Yeah, every construction site, you have different types of construction. Right? You have traditional block and steel, you have structured steel, you have casting, basically casting to do. This is one of the few sites in Jamaica that's going on now, and also infrastructure, some serious drainage infrastructure and sewage. It's one of the few sites in Jamaica that has all of the above. So pay attention, and it's a university tour you're going to get. It's a university tour of construction, great plan. That's everything. So matching plan, all of that. So pay attention. Alright?
Alright. Let's go.
Alright. Yeah man, big up yourself.
Smaller projects, the young men and women who bend the steel, cut the steel. And these massive projects where efficiency is key, and the volume and the lack and electric machine operation. Okay? These what we call stirrup or right? Those are the main bars. You have to put the column on the wall. Okay? Now you're going to go now over to the block making area and the backing plant. Measures here, equipment here that you don't see on a regular site, right? One such machine is the block making machine, right? Most sites that you will go on, the blocks are made elsewhere and are brought into the site. On this site, the block machine is right here and the blocks are made. Now, all blocks that are made that are used on construction sites are supposed to be certified by the Bureau of Standards. Why do you think we need certification? Anybody think? Anybody know? Huh? Right. You want to make sure that the blocks, the quality of the blocks, meet a minimum standard. Right? So therefore, if the block is supposed to break at a certain pressure or force, you want to make sure that those blocks break at that force. Okay? So here are the blocks. The process is the aggregates go into the machine. The aggregates now, sand, the gravel, cement. Now, because you're young engineers, I want you to pay attention to the sizes of the aggregates, right? For these blocks, the size of the aggregate in the stone is going to be smaller than the size of the stones that you use in the concrete. The reason is you don't want to see no big stone on the blocks, right? You want to see some small, medium, nice stone on the blocks. One of the things you have to worry about or figure out is how much cement you're going to use, to how much water you're going to use, to how much aggregate you're going to use. Because that is what determines the strength of the block, right? The strength of the block. And when the blocks fail, or if they're sturdy, it's going to be dependent on what you call the bonding, or the bond structure of the block. How the sand, cement, gravel, how it bonds together. Okay? So you have to make sure that you put the right amount of cement, that's all designed by the way, the right amount of water, the right amount of sand, and the right amount of gravel. Okay? One of the things about the block making machines is that it puts it in a mold. Right? It puts it in a mold. It also vibrates the mold to make sure, and of course, because it's a mold, right? The water content can't be too much. Because when you take it out, now the blocks just they drop down because it's too watery, right? So that's what I'm saying. Everything has to be precise. So the amount of water is precise. You put it in the mold, you vibrate it a little bit, that will allow the bonding to commence, to start, right? Leave for a little bit and then you take it out. When you take it out, the curing process begins. The curing process. The curing process allows it to cure or harden to the required strength that you design it to. Right? And that's important. Because if you use it before the curing process finishes, you can just use your hand and break it and you put and break it, which is not going to meet the required standard. Good. So, what we're going to do now, see them taking them out of the mold here, and they're transporting it from the mold to the curing area. Put it in an area like this, where it's exposed to the sun. But you have to wet it, damp it, so that the water doesn't dry out too much, and then you don't meet that strength standard that you want. Yes, it dries out too quickly. Right? Sometimes you see where they put tarpaulin over it, and they wet the tarpaulin to keep it warm. Right? Or sometimes they just drop it after a little bit, they put it in some water. Because after a minimum of 7 days, you can take it out, ready for use. That's the standard. But us in Jamaica sometimes we don't keep to that standard. That's why we are here. Make sure that material standards are done according to our Jamaica. Right? Alright, so yes man. By the way, you can ask questions at any time.
Alright, I realize that I'm sure six blocks per bunch, right? Yes. I found one female. Do you actually use a female within the main construction?
Oh, that's a very good question, and it tells me that you know about blocks. You know you have male and female blocks? Right? And how they match with each other. We put them together. Right? No. The regular blocks that we use in Jamaica, male and female. You're supposed to put a male to a female, a male to a female. So when you put the mortar in there, it sticks and burns. With the blocks that the Chinese make, with their machines, you don't have that. Male and female. All the blocks. I don't know what I'm going to promote. But all of the blocks them are the same.
Right. It's closer to the American standard.
Yes. Which is closer to the American. So what we do here, when you lay the blocks, you don't kiss it like that. Why? Because there will be no mortar that can fit in here. So you put a little space there. Remember you have your line? Put a little space and the mortar can't be too soupy. It can't be too much water in it. No. And then you use your shovel and put the mortar in it, and then you just use the shovel and come up like that. Block, seal. What is also important for you is that there's a horizontal steel, 3/8 steel that goes atop it every 3 block height. That is what you have to make sure you put in as well, because it keeps the building together, locking, right? So apart from this, right, when you have your horizontal steel, it also keeps the building rigid. Okay? But when you get into that, we'll go up, we'll look at the lane. If they're laying in the blocks. Alright, so you can leave that. Right? And you can leave that, you know. Alright, let me ask somebody.
When you become an engineer, tell person how to lay property.
Lay properly, lay properly. Hold it in there.
So, we have two persons who we know them can lift up the blocks, so we know them can lay the block. Now there are three types of blocks in terms of sizing. This is a 6-inch block, which means across here is 6 inches. Right? 6. You have a 4-inch block, so across here is 4 inches. Or you have an 8-inch block, so across here is 8 inches. All blocks, this distance is 6.5 inches, and this is a 16 or 18. 7.5? How much we say? 6.5? Give me a tape. Because I'm going to show you something. Pass a tape. Pass a tape.
This is 16.
Yeah, man, no. Pass a tape. I know this is 16. Pass a tape. Pass a tape. Not tape.
Everybody know what concrete is. Concrete is made up of three elements: coarse aggregate, fine aggregate, and cement. Usually you get a mix. Typical mix in concrete is what we call a 1-2-3 ratio. Now the first thing about the ratio that you must do is cement to fine aggregate, which is commonly known as sand, to coarse aggregate. Everybody remember how that works. Typical mixture is a 1-2-3. And the first thing is cement. Then fine aggregate. And everybody here is high school, so you can work out ratio. Then is coarse aggregate. So in this typical setup is 1 part cement, 2 part fine aggregate with the sand, and 3 parts. What's the next one? The coarse aggregate, usually known as gravel. Now, if you look over there, to your right, to your left, you see what you call fine aggregate, coarse aggregate, the sand, and the coarse aggregate, which is the gravel. When you finish here, we're going to touch it and look at it and look how we sample it. Very, very important how we sample the aggregate. Now, perfect example of a matching plan. This is the containers for the matching plan. Now, to the side there, in this matching plan, you have 2 kinds of coarse aggregate. Why they use 2 kinds of coarse aggregate is to allow for different mixtures. Right, you don't want one size coarse aggregate. And coarse aggregate goes up from 22 millimeters, which is less than an inch. Now, in here, so in here, yeah.
They use both.
In here, first process is to have the fine aggregate, coarse aggregate. Now, this is a control room right here. I'm going to tell you based on the type of concrete that you want. So So you have different type of concrete. It's going to tell you how much you want to mix. So it's going to determine the amount of coarse aggregate, amount of fine aggregate, and the last process up there is the cement, which is a half over there. That contains those starter ones, contain the cement. So come around just a little bit safer, man. You can make sure this equipment will back up right here. Come around just a little bit more. Come around, please. Come around. Look at the process now. It's very important that we time this and then we start. So this is coming out there. After the fine aggregate and the coarse aggregate has been mixed, it's coming out there. This I think right now what they're mixing is some black one. Right? So they're going to mix it. Then this is going to take it all the way up. And this is just the coarse aggregate and the fine aggregate. Rub and the sand mix together. Everybody hearing me? Mix together. It's going to take up and it's going to go into the mixture. Where critical elements, cement and water is added. The water is pretty strong. Because the amount of water that is determines how strong the concrete is. Too much water, you get a weak concrete. The idea is to start roughly about 35% water to cement ratio. So look at this now. So I think he just did it. He just did it. So now, the operator is going to allow for cement to come in. You look, the cement is coming in. The cement will be mixed in along with water. Now, after the concrete is mixed, the samples are taken from the concrete. And on this side we use tube, some sides we use cylinder. Depends on what the engineer specifies. When we go around there, we're going to look at the tube, and that's where we get the strength of concrete. The strength of concrete is used as a measure in PSI, pound per square inch. Now you will see on paper, 2,500 PSI. It is the crushing strength of the concrete. So when you apply inside a crushing strength, right, look, that's concrete coming out here now. Now, let us go back to the PSI. When they are crushing it, that's where you're going to get the strength of the concrete. Now, concrete can go up to 20,000 PSI. But the typical use, the most common use you here is 2,500 PSI. Right? And 3,000 PSI and above that, that's where you get your mixed design. Always remember that. Mixed design. So it's going to be determined now by the engineer. How much? Let's go back to the first. Cement, fine aggregate, coarse aggregate, water. That is added in there. Remember, one of the most important elements is water-cement ratio. And the water is going to determine how strong the concrete is. So here your uncle say, you want the concrete to be super, tell him, Uncle Joe, it's going to reduce water from it. Alright, now, let's go around to that side right now. This equipment here is blocking it now. There's a block blocking where the admixture. On this side they mainly use hardener, right? No, hardener usually be calcium chloride. Calcium chloride, any people supposed to know the number, right? And they have to come up with that and everything, right? Good. Here's the admixture over here. Right, Kenny, sit out, sit tree.
blockwork as well as structural steel, right? Because what? They call it beam, but you have beam and column in both. But it's very precise, right? That is, as you know, CMU, it's a block wall construction, right? It's also there. If you look over here, we call this, some people call it post and beam, right? And you see it's your columns out of concrete and steel, and the beams concrete and steel. So it's not those kind of structural steel beams and columns. These are concrete, right? So you see the different types.
So you think they're mostly they're mostly doing frame structure, that they're learning the two main types.
Oh, so the truth is, mostly yes. Mostly yes. But when we go down like to where the courthouses and stuff, especially those basement walls, those would have been reinforced concrete walls. Alright? Okay? Alright, yeah, we will look at that. When you say the engineer factor, cost and usage, cost and usage. Over here are warehouses. So with warehousing, what you want? You want wider spaces and higher roof. If you were to use a concrete, the size of the beam would not be right. But with the steel, you can get longer spans without the beams being excessive. Right? So that's the main concern. Okay? No. Yeah. Yeah.
I realize that you have to install your frame, your metal, and then infill the blocks to the structure.
Y'all hear what sir is saying? What sir is saying is that he noticed, right, that in both cases, you put up your main structural elements first, and then you infill with blocks. The truth is, you could have, once you have the main structure up, which is your post and your beam, your infill could be even cardboard, because the structural integrity of the beam is really the beams and column. But we're not going to use cardboard. Why? Because we know that in our country, it's on the way. We like sturdy things, we don't want a man can push the knife or not, right? We don't want nothing to come through there, right? And also our architects, we like fancy things. So when you put in your glass and the curtain wall and those things, you have to have these heavy structural things to hold them in position, right? So that's why we do that. And of course, when rain and everything come, you want to make sure you keep out the water. Question from the back? Yes? Why, that is a Chinese. You have different methodologies here. But what's impressive? You ask, what is that for? You see, when you cast it, you notice it's putting on the columns, right? When you put on the former, you might have some little ear holes, not honeycombs. Because honeycombs, you have to cut it out and fix it with structural growth. But what you have is just some ear holes in it, right? So all he's doing is using a paste, which is just a cement and water paste, no sand, and just roll it in. In Jamaica, well, I'm from the University of Western Zone Contractors, or WICO, right? We used to call it stop and wash, right? It covers all of those little holes. So when it's time to flush it, you don't have to build them holes again. Right? So it's called, we used to call it stop and wash, but it's a paste of just cement and water. Right? Fill out those little ear holes.
Are you still doing a rough cast?
Yes, that's still that. Yeah.
But normally,
But their rough casting is different from ours. If you look behind you, that's their application of it's almost, it's not a rough cast, neither is it a granite. It's a mixture of both, because they mix the fine sand and the rough sand and put it on one application and then
Oh, yeah, man. We do that. We do that.
Yeah.
We get one done. Get that smooth.
Yeah. Which can work now because a lot of these buildings is showing on. You're gonna put on it, so it makes that bonding easier. The texture is good, supports that bonding. Alright? Or somebody wanted to see, I'll just show you a column. Let us explain a column too. I'm a slave, man. I'm a boss.
Oh, they might come out the way I forgot.
Look, so probably they say they might go for courthouse and something. Yeah.
Make sure all the posts are in line, right? There's not people haphazard just put on posts and them people put on posts. Everything here is well calculated and measured as it has to be.
Yeah.
See that? Alright, so watch out now. Everything out of focus. What do you mean, sir?
Oh, your video.
Alright, see that out of this make dream? Look at now. Flexibility in this kind of construction. If you're coming in with massive containers and all of that, you couldn't use that. In other words, what I couldn't use, let me tell you what I mean. Those cross beams, you call that a mezzanine floor. You ever heard the word before? It means a floor between two levels. A mezzanine. So if this was going to be storing containers, no, you need a mezzanine floor because you're going to need a space, right? But if you're going to put a beam from here across here using a concrete beam, the depth of the beam will be taller than I am. The steel allows you to have that flexibility without having that depth, right? And also they can put in a mezzanine floor if you want. It's a floor within a floor.
So what he's saying in simpler terms, this span that you can acquire with the steel frame, you cannot get the same with the concrete.
Unless the beam is going
Unless
to
you design the beam to accommodate such, and it would require a lot of reinforcement. So in this case, the steel frame works out more economical.
This is called the depth of the beam. From here, so, to here, so, the beam. Because if you're going to use a concrete beam to do that, this same depth here would be probably my height. To achieve the same strength. Right? So understand that?
Daniel.
You understand that? When you stand up over here, it's called a manhole. A manhole. Despite what people telling us, a manhole name, right? And what happens, it carries this one, carries fewer. Those steps are steps to enter and leave the manhole for maintenance purposes. When you look down there, you'll see a half a pipe, right? That's really where the sewer is supposed to come out and traverse. And what they've done around it is called benching. No, that is not yet finished. Because the benching, when you're finished, the finish that's supposed to be on it is called a steel float finish. Very, very smooth. Because you don't want anything to be sticking to
The surface.
the surface. Thank you, sir.
So
Nothing
at your homes, around your homes, they don't. It's not actually a manhole at your home. It's an inspection chamber. Because as you see this, a man supposed to can fit in it. That's why it's named manhole. But at your homes, what they call manhole, they are not actually manholes. They are inspection chambers.
Right. Alright? Okay. Let's go. Colin,
So he has a question. I have one student who has a question
yes.
about.
Hold on. He has a question first.
Go ahead.
You have to say it loud that they can hear it. Students, one of your colleagues have a question. Let's go.
So earlier when you talk about scaffolding and stuff, we have a question. So where you know exactly like where to place the scaffolding around the where how you know?
Alright. So remember I told you you have to have a certified technician to do it. So they would have already worked out, right? How far the distance between the building and the scaffolding, one, and that's very important, as well as the spacing between the different members. What is going to determine that is the length and width of the board, the scaffold board that's going to be put up. Remember, people going to stand up on it. But you don't want to have a scaffolding board that when you put it so wide, so far apart, when people stand up on it, it flex. Nobody knows how to do that, right? So you have to give it a spacing, right? Reasonable spacing that will allow the board to be put up without it flexing. And the scaffolding boards are typically 12 inches wide, right? Probably 16 inches, 12 inches, 12 feet. So 12 inches wide by 16 feet, 10 feet, 12 feet, whatever, right? But you want to put it so that when you put one across to there, when you step in the middle, two people, you don't have it wobbly, right? So that would determine that. So that's on the scaffolding.
Excuse me. What you asked a while ago, you got that was structured for the technician do it. That one, right?
All right.
You're going to see that one.
Yeah, man. All right, thanks. You had a question?
Where the
Oh, hold on, before you ask. So that's one. The scaffolding that's put inside the building now to facilitate the decking. Those are different. Those are structural design based on the weight of the concrete and the beams that you're expecting to hold. All right?
where the sewage plant and the treatment plant?
Excellent, that's an excellent question. When this facility was first designed, it was designed to have its own on-site mechanical treatment plant. However, the decision was taken to upgrade another sewage treatment plant called the Red Hill Spent Sewage Treatment Plant, which is further down the road, and have this big gravity fed and then pumped up to there. I like that idea because rather than have two facilities, you have one. That's one reason. The other reason is that that facility will have the effluent, which is the sewer, not just from this facility, but from other facilities all around, right? And I like to have less facilities to maintain, right? So just upgrade that one.
So you're going to have to construct a lift station.
A lift station, yes. So you gravity feed to the lift station and then pump through what you call a force main to that plant. Okay? Anything else?
What do you think about it now with that? What it do with the waste of that
No. It's a treatment plant. So our laws in Jamaica, as stipulated by NEPA, is that all the sewage has to be tertiary treated. Which means Which absolutely, which means that when it's finished, it's pretty much safe for human consumption. That is why the sewage treatment plants have to be very well maintained, especially in areas like this where we have aquifers, because there are about 4 or 5 wells on this property. So you don't want to have anything that's going to contaminate the aquifers. All right? So you're going to have to be, or NEPA will have to make sure that they're particularly vigilant to ensure that the effluent from that sewage treatment plant is treated and treated properly. All right?
Then why we can't invest in our own human resource so that we can do this project we send for capital contractors.
That's for another discussion.
It's a geopolitical.
Same thing. Oh, you look over there. There's different things. The 2 scales. What's important is it? No. It's something engineering. Once you're using, you have a steel line going to use another steel of the same, of course, to the same size. The splice length is important because what you want is for that steel, although it's joined, it has to operate as one. Like it's one piece of steel. So the splice length has to be accurate, right? And that is normally 40 times the diameter of the steel. 40 times the diameter of the steel. So this steel is a 5/8 inch steel. And I know, I don't read nothing. I know because I'm in construction many years. So 40 times 5/8 is what? 40 times 5/8. So my kid can go in a 45 times enough.
Yes, 5 times.
So 5 5 is 25. So it must be 25 inches minimum, which is just over 2 feet. So if I measure that and it's under 2 feet, now I'm going to pull it up and redo it. But I look at it and I know that it's more than that length is more than 2 feet. How I know? Because I know the spacing is 8 inches. Right? So I don't see when I tape it, not because I'm lazy and anything. But I'm around the construction now. And I know what the space is there. So I just keep it like that. You understand? You know when you start, draw a tape. Please, it's not to the bit. The hand up. Okay? We don't follow upstairs. And my chairman is showing me this one that is less. But I say to your chairman, that this is a different bar. All this is doing is holding it. Yeah, because this is the door. Alright? You have a question now with it. I'm happy with that.
Yeah.
Sure.
Yes.
Right? So in case of like a power cut, a power outage, or a malfunction,
Right?
wouldn't you need a staircase
What an
for that
excellent
purpose?
question. What an excellent question.
Sorry. Excuse me. Come around for a minute, please. Sorry. Come around. Please, ma'am.
So-
You can pose back your questions to your colleagues.
I was asking,
This is an excellent question, by the way.
is the elevator.
Right.
So in case of a power outage
Right.
or a malfunction of the elevator that would cause it to stop working,
Right.
wouldn't you need a staircase?
And they're absolutely, so that's a question, so the answer is yes. And all buildings in Jamaica by code, by law, right, must be designed with multiple types of access. You're either going to use staircase and elevator or staircase only. Because not just in case of a malfunction, but in case of a fire. Okay? So if you look behind it, you're right, you'll see one of the staircases that will be used, right? Several of them, right? And every building has several staircases. As I said, not just for the use because the elevator is down, but the fire code that we use here in Jamaica necessitates or ensures that you have proper fire access in case of fire. Sorry?
I just wanted to explain the design of the beams and whatever hole in it and
The truss system.
the
Trust system, yeah?
But I realized when I know that because the cast in there up here.
Yeah.
But I was able to one saying that it was touch why it has so many holes in it and the truss system is up.
Well, the holes in it are twofold. Right? One is architecture. Let me say that first. One is aesthetic. They look good.
Yeah.
If that a solid piece, right? A solid piece, right? Don't you have a solid piece? It would still work, right? But there are two issues. Remember, Mr. Batson spoke about efficiency and cost, right? So you are having a member, right, that not only looks good, does the work, but in doing it like that, it's more cost effective, right? Because remember, steel, for who don't know, is the most recyclable material in the world. So why are you going to put all of that where you don't need all of that, right? So that, of course, helps with the cost effectiveness of it. And it comes down to steel. Steel is always measured by weight. So the less weight you can use, and the less weight also in terms of the ease of construction and lifting, good. And it works in terms of it satisfies the design parameters of the engineer, which means that it is able to transfer the loads that it expects. Remember, there are two types of loads, right? One is live load and dead load. All right? So all the conditions. Does it satisfy the load requirements? Tick. Yes. Does it satisfy the efficiency in terms of cost? Yes. Does it satisfy the ease of construction because of the lighter weight? Yes. Does it satisfy the condition of it looks aesthetically pleasing? Yes. Tick.
In this case, like the concrete and support and stick in the deck, right?
Yes. Yes. What this kind of construction allows as well, I'm glad you mentioned that point. You know, you don't see a lot of cables and conduits and all of that. It allows you, the end user, whoever is renting this space, to move, to put their services where they want. And then, you know, if you know the slab already, you have to now cut again and cut back what you know. Right? All you're doing is putting it within the ceiling.
Part of, just to add to what Mr. Kennedy said, part of the roof structure, and this is a roof and floor structure. Part of it is that the entire floor system is called a composite floor system. And what it is the corrugated sheeting. You see there? And what that means is the movement of the sheeting. And then a BRC mesh is put there, and then concrete is added. So it satisfies the requirements, similar to how you would have steel infused inside of the concrete. So you get reinforced concrete, it's satisfied the same need. And the entire structure is a lightweight structure.
Oh, so you're saying in this case then you would want to put in a half-inch and support in this that's the BRC.
Right, yes.
And then now, in that service, there would be any need for any over support.
No. I remember, you're still using a beam system.
Right.
So it's a floor system that you're putting in now, right? And the floor system requires movements and everything on top of that.
And by the way, the BRC mesh could have been replaced by something called fibers. They put fibers in the concrete, right? Which does the same thing. Keeps the concrete together and prevent it from dealing with it in tension. Remember, concrete again in tension.
Critical aspect of concrete work. A homogeneous situation in concrete is that concrete is strong in. Remember, concrete is strong in.
You.
Properties of concrete.
You know.
One
Yes,
of the main
because they-
properties of concrete. No, properties of concrete. Yes. Oh, concrete is strong in compression.
Which means that they can push it together.
Right. So, and then the
Push it together.
steel is strong in tension. And
That's
tension
right.
is what? The pulling of the car. Tension of force and compression is pushing together. And that's why you see the concrete beam, it have a little deflection in it is when the weight is going down on it. And the forces in the concrete is resisting the dead and live road. And that's the teacher tell you anything about shear force? Shear force is total internal force is resisting. Anyway, let us talk about that.
The shear force, no, but that mentioned is steel cutting that fixed on here.
Sorry?
Yes.
No, I'm saying.
The shear force. When we talk about steel cutting, when I'm shear.
Okay. So remember what concrete is and remember what steel is. So everywhere you go, you see an example of how material is used for construction and different kinds of structures. So far, maybe two kinds of structures that we have seen. Two main kind of structures that we have seen. Huh?
Steel and block.
Post and beam, which is another skeleton frame.
And the steel.
On the steel structure. Right. You see the structure on steel? Right. So you have seen two main type of
Post and
structure.
beam is steel and concrete in composite. This now, which is the structural steel, is just steel alone as part of the main structure. You understand? Let me say it again. Let me say that again. Sorry?
Look at out of things.
Yeah, man. Go on. Right spot. Say it right spot.
So the steel with the pillar.
Color?
Yeah.
So if concrete or something doing the column itself, it's support compression or
Alright. So the main issue or the main detail we have to understand is columns and beams and how the loads, dead and live loads, are transferred from the building to the ground. It's transferred through beams, well, floor, beam, column. You understand that, right? So having understood that, let me say it again. You have the floor, column, beam. Main ways of bringing the load, live and dead loads, to the ground. Well, you have two ways of doing it. You can do it through the structural steel like we're seeing here, or the concrete and steel beam and post setup. You get that? Yes. It's simple now, don't it?
All right.
Alright.
Quick question. You said I want elevator. Which material the elevator?
The elevator has different types of material. Steel, aluminum, cables, different types of material.
So each elevator manufacturer, they use a lot of aluminum. Each elevator, they use a lot of steel now. Elevators are coming totally different now. Before you had what you call a car house on top of a building. Now the motors are on top of it. Elevators are coming in many
Because you know why
ways now.
we're looking at more using materials more efficient.
Yes.
Right? So I don't know it's big wood, but steel.
Who knows? Carbon fiber might be next.
Yeah, who knows, yeah.
Who knows?
Which is light. But a lot more lighter weight materials are used.
And that's where different mechanical engineers are in the construction industry now, designing those things.
Right.
Electrical engineer coupled with mechanical are designing for that, for different elements inside the construction.
You want to make the building lighter, but you want it to meet all the structural conditions. Right? All right, let's go.
not saying I will take it.
Remember we spoke about reinforced concrete in cast in place, or we call it cast in situ, INSITU. Cast in place. I think integrate that principle. Meaning cast in place, right? So here it is. We have the inner facing of the flag. Right? So when they're finished putting that up, and battening it up, they're going to then install the outer face, right? And then they will pour the concrete and vibrate, right? So this is another methodology. So you'd have seen CMU, this is block and steel, right? It's reinforced concrete in terms of column and beams, and here it is now you have reinforced concrete walls, right? You have buildings that are predominantly designed not using the post and beam setup, but reinforced concrete walls. This is what it is, meaning this is the methodology that they use in terms of the reinforced concrete walls. And when they're doing buildings with reinforced concrete walls, you don't see any column and beam and all of those things. Certainly not to the extent that you're seeing now. All right, so this now is a fairly new type of former called fair-face ply. All it means is that you get, when you pull it, the finishing on the concrete looks a lot smoother. Right? Looks a lot smoother. And it has, because of that, you should get more uses of it, because what you want to ply is the repetition of usage. You can use over and over again. So if the other ones you can use 5 times, this one you probably can use 6 or 7. You have a question there? Yes. So that air compressor machine, Mr. Deere, is when you go up on the other level, you have some compressors where they tighten the beams, the bolts and nuts, it's air guns they use to tighten. Right? And I don't know some man and wind them up now. Efficiency, remember I tell you about efficiency? And it's set at a certain, we call it torque. Right? Because all of these have to be tightened to a certain torque. So you just set the machine and put it on it. And when we get target, so you don't have to double check and triple check. Right? Efficiency again. Alright. If you notice, this is some cutouts in the floors, right? Never heard about construction joints? Of course you have, because the teacher tells them teach you know. So Claire, you know why do we need construction joints? So there, why we need construction joints? What do you think? Huh? 2 billion watt, that's a good start. 2 billion watt? Yes? That's a good start. What are you thinking? Alright, that's a very good start. Very good. So, what you know, right, is that, sorry? Good, that can work too. What typically happens, right, is that you can never compact this area. So every single square inch of it behaves the same way. And because you know that, you're going to have what you call differential settlement, meaning that over there might settle a little different from over here. So what this does is that you allow a control point for if the movement takes place, it doesn't crack, it just takes place within where you want it to take place. Right? So it don't dry as an entire floor. I have crack all over the place. It pretty much acts in sections. So you can have a little slightly differential settlement. That air settles, then this air settles, and it settles within the crack, within the confines of the cutout.
So you're basically creating a predictable path.
Absolutely. You have all the words to it. Yeah, man. All bridges have it. All bridges have it. All bridges have it. Because
it
members
move.
Yes. And in fact, with those, they put some rubber thing in it. Right? Because you want it moved like that. Alright?
Yeah, cricket pitch. Cricket pitch. Building.
Floors and how them put what where and based on the demands of the building and parking and all of that stuff. Planning of what they're the way and located where and spatial requirement. And between themselves and the plan back and forth and say, yes, that's it. And they bring the engineer in now to design how you will make the structure work. Architect design some pretty things. And engineers now come and say, alright, this is how you're going to have to make it. Size of foundation, size of column, how many space, all that stuff. And how the drainage going to work, how the sewer going to work. Not final, I wouldn't say final. Everybody has their own value with an art. You understand? Everything. All right, gentlemen and ladies, we have what we would like to think is will be the most modern courthouse in the entire Caribbean. Right? It depicts justice. You notice you have 8 columns at the front. You know, it has an imposing feel. Of course, this is St. Thomas. This is Paul Bogle's country, right? It says justice and justice for all, right? Despite where you come from, despite the ethnicity, despite how much money you have, justice, right? For all, right? As I said, it's very imposing. It tells a story of everything in Morant Bay, St. Thomas, being according to the law. And everybody has their own, you know, feel, but everything is done in accordance with the law.
The most modern courthouse
In the Caribbean.
Oh yeah? And it has 5 different courts operating.
Different courts operate at the same time, right? You also have 4 levels plus the base, 3 levels plus a basement, right? It's so what we call purposefully designed. We have the judiciary, which is the judges and the court support staff, being mixed, but mixed with persons who are convicted or maybe convicted, who are being charged, in a way where there is limited interaction outside of where interactions need to be. It's safe, right? Persons don't have to worry about your safety, right? As I said, it makes you feel like you're in a space where we all can coexist respectfully, right? So we're happy to be a part of this. As I said earlier, it's the most modern courthouse in the entire Caribbean, and it will be a showpiece for us, for everybody here to be proud of, to say we were here, we saw it when it was being built, and and how it is operating, right? So as I said,
Sure, you don't have to visit here.
if you're visiting, you must be a visiting attorney. You must be a visiting attorney.
A lawyer.
Or a judge.
Sir, when you think though, we gotta be first to go back again.
Yes, ma'am. Not to be tried as anything criminal.
Sir, are there any of the plans that you have that you could share with us for them to look at?
We're going to go down there.
When you go back there. You have a creator open over here.
Sir, it's a pot.
Just some important.
When the grand opening, you hear me, Mr. Baker?
Yes, we do.
One of the things that I want to show you, right? I want to show you little thing about this thing. We have the basement. See that black paint there? That's waterproofing, right? Because it's going to be covered. Anywhere you have basement and stuff, you want to have proper waterproofing because you don't want water to be coming in after it's on, right? after we gone as the engineers and the contractor them gone about them business. Right?
Yeah, I'll probably call it.
We're gonna make one further stop around here.
The mesh, please.
Sir? Oh. No problem. We're gonna make one further stop around here to look at some critical infrastructure. But one critical thing here, I want you to know, see that green mesh there? That's put on the scaffolding.
Yes, sir.
It's a safety measure. It limits debris from falling from upper floors down to lower floors.
Yes.
Very important. And it also limits the wind and the dust that is blown from the site to the workers who are working in that vicinity. You notice, you see it going up the top, right? You don't want a whole lot of dust blowing in. So it acts both as a dust mitigation measure as well as a fall protection, right? No debris is being thrown from there to affect the persons working on the lawn. All right?
That's a hoarding, all right?
That's called a hoarding. By law, construction sites have a hoarding. The persons know. All right, this is our final stop. In engineering, right? That's why we like engineering. It covers everything that you can see. One of the impressive features about this development, right, is the drainage infrastructure, right? Now, when we design for infrastructure, we pretty much design for events. One in 20 years, one in 25 years, one in 30 years, one in 100 years, right? What we're designing for here is a one in, I think it's a 1 in 80 or 1 in 100 year event, right? However, this is called a detention pond, right? And what this does, all the surface water, and you can think about it, look at all them roof there, all the water that comes on the site is channeled to here. And what this structure does here, right, is it tains the water and then lets it out in the main drain in controllable flows. Because water in and of itself is not dangerous if you can control it. It's when you can't control it, that's the problem. So beneath this area of, we call this river shingle, now the aggregate again, so the size is big and varied out, right? Beneath that are some what you call ADSL pipes, right? So some big corrugated plastic pipes, and on top of them, we perforate, we bore some holes. So the water that comes and sheet flows is going to go down into those pipes and then go down into that chamber and then disperse in controlled volume or flow. Everything else that is going to come from there will come through that drain into this chamber, controlled going out again. A very impressive structure, and it will control and ensure that there's no flooding going out on the road and messing up the place on the road.
All this area will be landscape.
By the way, yes, you won't see this. You won't only see the top here because it's going to be landscape, nice and lush and steep. You, because you're here in the construction phase, you know. So,
it's going to be a drop trail as well.
Yes. It's going to be a jogging trail as well. Alright? So, as a matter of fact, what the chairman would like, like he said it, but he wants here to be a nice entertainment area. It's like never know some people come and put up the trees, and that's what we'd like to see right here. An area where people can come and just enjoy themselves, almost like picnicking. Right? So that's what is going to happen. what I'm saying. This is part of the drainage structure. It comes in, you know, eddy current and kills the eddy. When the water comes, a lot of flow, it dissipates the energy, kills the energy. And so it keep the energy and let it out in manageable portion. Yes. Absolutely. Absolutely. All right. So this is a very impressive part of the development. Sure, very proud of it. All right.
So this is where the park is gonna be as well.
You're gonna have yes. Parts of it.
Past this stage now where you have to do certain things. But what you need to do now is put things into action. Decide which area of engineering you want to be. Focus on that area of discipline. Do your research. Find out who in that discipline is the best engineer globally. Read about that person. Buy books about what they need to reach where they are. Right? And walk through life. Do your research. Whether it's civil engineering, structural engineering, electrical engineering, mechanical engineering, whichever one. Go out. Google now can tell you everything you want. Find out about the top 10 engineering specialists in those areas of discipline and find out how they dedicate to it. Read about them, study their patterns, see the challenges they go through. I was speaking to one prominent success businessman this morning, telling him about the Women's Center that we are going, Prime Minister mandated us to upgrade to a nursery and a dormitory. You know what he said? I wish that had happened in my time because my mother was one of those victims. And both of them had to be adopted in a friend's one-bedroom unit. Today, government has 14 women's centers across the country. Looking out for the young women who got pregnant at school, and instead of being thrown out and retard your schooling progress, send and take them in, take care of the child, and keep them in school. In a school at the center with the same curriculum that the school had before. And you have heard the Prime Minister and Minister of Culture of the Way said, for the first time now, we are going to ensure that teachers from the Ministry of Education are sent to those centers to carry on the level of teaching at the standard that you would have left your high school. I think big up the government for that. Big move that is. I say this because I see quite a lot of females here. Right? And I would hope to God that you would not be in such position. Right? Because you are focused and you have your head to achieve your objective. And I say to the young men, if anything happens, it can't happen without you. You don't make it happen. Finish school too. Right? And be the best of what you be friends. Here a young man said to me this morning, I was surprised. We go young men school together. We have never taken a picture you and I, right? Can you imagine in this modern time, know your history, know where you're coming from, build friendships. Jamaica is who know that can help you to guide you in the right direction. Okay? Build friendship with your friends. Build good partnership that you all can be proud. So today this trip is about capacity building. Not only in engineering, but in what? Moral values and attitudes. Which you could be the best of engineers. You don't have moral values and attitudes. You're not. Okay? So thank you all. I'm going to hand you over to my managing director, Dr. Donald Clark, who is an engineer too. And he will tell you about some of the career actions that FCJ also might want to offer you as young apprentice, that you can come on our site. I don't want to claim what he has to say, but I'm sure this will be part of his presentation. God bless you.
Rare. So I'm a country boy, just like you guys. I was born in St. Elizabeth, in the hills of St. Elizabeth. I'm from a family of 16, the last of 16, the last of 10 boys. So teacher said to me earlier that how does somebody leave a rural community to become a doctor? And I'd love to just start there because I view myself in you guys. And I think the first thing that you have to do is believe in you. Can I tell you that? In my rural community, we did not have electricity when we were growing up. And I actually wired my house using batteries and bulbs. Every room was lit in my house. So actually, I became an engineer before I knew I was an engineer. So that's the right thing you guys have to start. You have to believe in yourself and you have to decide what you want to become. Secondly, I'm not one of those who is very fearful that finances is the only thing that you require to be successful. Because I believe you have to have the drive. Kirk and I went to Trinidad and we studied engineering in Trinidad. The way I ate in Trinidad, Kirk tells me we ate because we have a thing called boats, where you aggregate together, you cook and feed each other. So I did get student loan, yes. And can I tell you too, when I was in Trinidad, I started that t-shirt business. I said to teacher a while ago, I got my girlfriend pregnant at age 19. I worked for a holiday shop and purchased a Hillman on-top car. And when I was in Trinidad, if I run taxi out here and try to feed my young daughter, and it is that you have to know what you want to be, you have to have that drive, but you also have to work. Nothing that you require is going to come easy. You have to work. And I must say this also, that when I came to Kingston Chairman, I think one of my teachers said he could not read and write in grade 9. When I came to Kingston, I could hardly read and write. My sister used to have the book beside me while I'm eating. I came to August and conventions, well, I think in February somewhere there, Chairman. Believe it, I could hardly read and write when I came to Kingston. And as the gentleman just said, I went on to CAS, UTEC, 2 masters, and a doctor. See a little beautiful country boy used to walk probably easily about 8 miles to school. And I'm standing before you here as a testimony that you can do it. So please, after you leave here today, tell yourself who you're going to be and start working up to become who you want to be. Secondly, let me just chat a little bit about the type of careers that are out there. So there's my chairman over there, he's an engineer. There's Kirk, who is a general manager, owner of a company, he's an engineer. And I'm the managing director of the company. So the truth is that your career opportunities are going to be multifaceted. When we conceptualized this project, the Prime Minister himself was at the table, Chairman. So it took even the Prime Minister in his job to make a project like this a reality. So we have persons who was at the table as part of the conceptualization. I would say we are the strategic officer. That's the person who does the business development for FCA. We have our estate manager. That's the person who manages our property. We had our corporate officer, another business person. He does the business development for the company. And of course, you have the chairman, you have the MD. The point I'm making, you can also be involved in development with different types of careers. So even though today you are saying that you want to be a construction engineer or a civil engineer, along the way you can become many different persons. So it's a matter of studying and creating yourself. That is a transformational process in my own opinion. So let's talk about the classification of engineer, and so Kurt can come in and help me. I'm an electrical engineer. So a big project like this have what we call an MEP, the mechanical and electrical plumbing engineer. So that is the ear of the operation that designs the electrical and the plumbing. All the high voltage system, the JPS line, the elevator, the AC. So if you love that type of thing, you say you want to be an MEP engineer. I think an electrical engineer is the best engineer for my So I think of an electrical engineer as a generalist. Because I think of myself as a generalist. Anything I want to learn, anything I want to do, I just think I can do. So I've been a manager, I've been an engineer, I've been a chair, I've been anything. So I'm saying the MEP is the engineer who is responsible for your plumbing, your electricals, and your high voltage system. So if you're thinking about it, I would say you should become an electrical engineer. But a building like this has to sit somewhere. It has to have the right structure. So the structural and civil engineer is important for this. So we have a structural engineer. Sir, what's your role, sir?
The drains and this position and the sewer, the water runoff, where it goes, the flood.
And that is so important. As a matter of fact, this particular property, if I believe that say 100 years from now to have a flood, so we need it to live. Yes. So the place is designed, the structural engineer ensure that 100 years from now when the flood comes, this place will still stand. So if you're thinking about it, you might want to build a structural
the outside, drainage, sewage, structure outside. And then below the structure is a geotechnical. So you have to make sure everything is done what is going to be done. And so you have to ensure that what is below ground can take the weight that you're going to use. So you have to make sure that you don't have improper earth conditions on the way. And if you do, you may have to put in piles and all those things to ensure that the structure is going to be.
So the architect to me is the man of color, the man of imagination. So when we came to the table, the dreamer, we sat with the architect and we tell him what we are thinking about, what we want to do, and he went away to share and came up with what we call conceptual design. And a matter of fact, when he went to the Prime Minister's office and presented it to him, he said what his own really soon chair. And we have to redesign. So for me, if you're very artistic, and as Kurt said, you are a dreamer, being an architect is probably the place you want to look at. And in this project, and in many projects, for architects, is sometimes given that overall coordination responsibility for the engineer. Not in this case, but
let's just tell the gents of that. So, way back in the day, the architects used to, because they're dreamers, they used to let them coordinate everything, coordinate different functions, engineering functions, and then the building and all that. But they realized that a lot of creative people are not planners. So creative people, they're very creative, so they don't pay attention to certain level of detail and planning. And so the whole matter of project management was born. And the project management people are the person who plan entire execution start to end. From one to two things are project. One, starting, and two, that's where the project management came in now. Learn everything. Of course, you have to have good knowledge of architectural work, engineering work, some different facets of engineering. The real government agencies, the whole statutory things and all that, because you have to do all of that within the context of the laws of the land. Right? So that's where the project management minds us come. Right? So just to make sure that all eyes are dotted and all things are done.
So finally, Chairman, and if you just allow me to so FCJ does employ technical officers. I think, Chairman, since this group is the first group to come to us, I think we should do one like that. Commitment when we want to some accommodation of the technical students to work with us. If they are able to find accommodation here, we have any project happening on that side as this one. But we do have properties in Clarendon and we do have properties in Manchester. Unfortunately, we don't have any properties in St. Elizabeth. I was just saying, we do hope to get some land at some point. Right now, Chairman, if you could help me go on record, we do have the Prime Minister's whole program and we do have the accommodation to employ a number of youngsters within that program. So we love to do that, Chairman. The team, the opportunity for you. Anyway, guys, thanks for coming and hoping that you learned a lot today. The transition of the project goes to September, probably latest December. Feel free, if the team want to come back and I see my chairman, extend a special invitation at the opening, but anywhere along the line that you guys believe you would want to come and engage. And I think my number for the team, I'm sure Chairman and Kirk will say, we haven't had no disagreement for us to the team that is here. So any of the guys want to call us to clarify about what it is to be an engineer, we'll make ourselves available. Thank you guys.
Special prizes. I mean, so we don't mind going back to the same and so getting on board. So the chairman said about it, you can use this to measure your life. So this is actually a flashlight, it's actually a tape measure. And it's actually a food right. So we're giving you 3 months. We actually started out the career as a construction. Some kind of career. So we're giving you this. But I have, what's his name? What's his name? Watson. So I'm going to ask one question. So we have this model that we want to give. It's an SPJ Watson model that we want to give away. So yes, you just ask a question based on your signature.
All right, presentation.
Just one question.
Mr. Kennedy alluded to this one. Anybody.
But you have to raise your hand.
Name type of structure of this one. Anybody, two main type of structure. So,
You forget already?
right. Yeah, go ahead. All right, give me that one. I know you have it.
Next one.
That's a reinforced concrete. That's just all. All right, post on me, get it. That's a good one.
Mr. Cherry, you want to come and
Yes, post on me.
So when you're
So
drinking
it's
all
not
the
just here and post on me, otherwise known as a skeleton.
Hold on. And I'm happy that it's a young lady who got the prize. Well, I'm trying to compare to the SPJs as well. All right. Karen, I'm going to ask you to give away this next one. Chairman, you have that certification. This one is so easy. No, this one is so easy. I said it at the start. What's the square footage for this development? 436 See there?
436,000.
That is it. Just like
Go ahead,
that. Just like that. Oh, you want to take a picture? Hold on, they want to take a picture.
Ready? Good?
So again, thank you very much for coming. As you make your way to the bus, you can just collect one of these for Oh, okay.
I nominate Mr. David. Thank you. Seriously. Watch it now, Karen.
Alright, so on behalf of on behalf of the St. Elizabeth Technical High School, we would like to thank the Ken Casa and FCJ corporations for taking time out of their very busy schedule to show us the elements of this huge project.
So maybe I should ask, based on what you see, how would that help you in terms of your studies?
So the guys kind of push me to do more in the building and technology. So, but
More than I did before. That's it.
And you have never done a different discipline and what you're very Okay, teachers, parents, students, where's the driver?
we can get a picture with the teachers, please.
I would ask, ensure no speeding on the road, teachers. Take your own time, drive safely, get home back safely. I know you have a long journey ahead of you, but it was indeed a pleasure having you. Oh, you were so bright, so enthusiastic. Go with peace, and I'm going to ask, you know, away of Ken Casa being a project manager, he's a lay teacher. I want to step forward and just give a word of blessing for you that they get home safe.
Wait, before, give me the picture first, please.
Alright, okay.
And then you straight ahead. Show a little teeth, man. Why so serious?
Stop by top smash. Oh, you want to be one man in the can't
Let's have some burgers. Your mom has been gathered here today. You know we had a great time. You said the Lord went to and me and gathered. Your presence is in me. Lord, you showed us all a great time here today. Because you have done a lot. You gave me the knowledge that they would have done here today. And help to guide them as they make their career choices. We pray also, dear Lord, that the food that they will eat strengthen their bodies as they now get ready to take a long journey back to St. Elizabeth. We pray, dear Lord, that you take them there safely. We ask you to keep your hands on the driver's hand. Make sure that he does everything he's supposed to do to drive within the law without any sign of recklessness and get these wonderful young men and teachers